Oh, okay, Maureen, we'll get started. We'll do our homework, and
Uh-huh.
then we'll do some more exponents and radicals. And one other thing I wanted to go over with you is rationalized radicals, and that all that's doing is really making, when you have a square root in the denominator, make it a rational number. We'll get to that, and then we'll go through the scientific notation. All right, so we'll look at. Uh, let's see. Can you see the screen, the homework?
The homework can come in.
Okay, so let me do a new share and bring up the homework. Now, do you see it?
Yeah.
Okay, so let's do our homework on exponents and radicals. And I had scientific notation, but we didn't discuss that so much. I just wanted to see if you wanted to try it. But anyway, we'll do some more practice on the scientific notation. Now, Maureen, I think you had 3 for that one.
No, I had number 2.
You had number 2. Why number 2?
I ain't got a clue. They just guess it because I don't understand it.
Okay, Maureen, that's why. Okay, well, hold on a minute. Let me do a new share. And you're not the only one, so I think I'll go through let's see, exponent properties. Do you see the exponent properties?
Yeah.
Okay, because I think there's misunderstanding on this, because you're not the only one that missed that. Now, the exponent properties. Now, look, the first one is a product of powers. So when you see same base multiplied, you add the powers, right? So all this means is, and notice I put the number here. This says x to the n times the dot there is used for the multiplication symbol, because you're already using x. X to the n times x to the m is x to the n plus m. So that's a product. And a product is what you get when you do what, Maureen?
Multiply.
That's right. Very good. The multiplication operation gives you a product. So if you multiplying exponent, you're multiplying here factors with the same base. X is the base, n and m are the powers or exponents. You add the powers. So if you were given, say, like 2 to the 3rd times 2 to the 5th, that's a multiplication, and you add the powers. 3 plus 5 is 8. Now, is that clear?
Yeah.
Okay, so if I gave you a sample question and it was a multiplication with the same base, then it would match the property number 1. Got it?
Yeah.
Okay, now number 2 is what? What kind of mathematical operation is number 2? Maureen?
A subtraction.
No, that's a division.
A division.
Yes. A numerator over denominator is a division.
I do it over, but I didn't work it out. I think I put number 3. I text you said if I can correct mine. And I put the answer for number 3 and
right.
number 2. And number 2 I put put C, but I don't know if it's right.
Okay, so
yes,
you're right. That's correct. So you corrected those 2. Very good, Maureen, and you're absolutely right. So I thought when you looked at them again, you'll see, okay, I can do this, because this second property is division. It says x to the n divided by x to the m. You subtract the numerator power, and that's m, from the denominator power m from the numerator power n. So that's x to the n minus m. Now over on the right, you have numbers here. Now, what is the base right here, Maureen? What's the base?
3 and 2.
No. Base is 3.
3. Oh,
The powers are 8
8
and
and
2.
2.
That's right. And what do you do to the powers when you're dividing, Maureen?
You subtract.
So what would you subtract here?
The 2 from the 8.
That's right. And that's how you get 3 to the 6.
Oh.
Okay. So that's called the product of powers, and 2 is called the quotient of powers, because quotient is what you get when you divide, right? Okay. So 3 to the 6 is the quotient of dividing 3 to the 8 by 3 to the second. Now, is that clear for the division, Maureen?
Yeah. Yeah.
Okay. Now, number 3 is a power of a power. In other words, you have a power inside the parentheses
And a
and a
power
power.
outside.
That's right, Maureen. Very good. And what do you do when you have a power inside the parentheses and one outside? What do you do to those numbers, those powers?
I think multiply them.
That's right. Very good.
Yeah.
The dot here is multiplication. So like n x into the n, all raised to the power m, you multiply n times m. And then when you put the numbers in there, 5 to the 4th raised to the 3rd power, what do you do to those powers, Maureen?
You put them over the 5. 5 to the 12th power.
How did you get 5 to the 12?
Because we multiply the 3 by the 4.
Very good.
And they had the 5 there.
Yeah, the 5 is the base. So you multiply 3 times 4, and you got 5 to the 12th. Very good. So, and now these numbers could be, remember I said the powers or exponents can be 0, they can be positive, they can be negative. So in that first question, I gave you a negative power of 3. But remember, these rules hold whether the exponent is 0, positive, or negative. All right. So power of a power, power n, and then the power m for what you see in parentheses. Questions on power of a power, Maureen?
No.
Okay. All right. Now, number 4, and the parentheses kind of dropped there, but that's a parenthesis right there. So that's x times y is what operation, Maureen?
Yeah.
What mathematical operation when you see x dot y? What operation is that?
Okay.
Multiplication, division, subtraction, addition. Which one?
Multiplication.
That's right. X times y. That's what that dot means. X times y. And then you raise that. X times y gives you a product, and you raise that product to the n power. So we call that a power of a product. In other words, the product is right here, x times y, like you said, multiplication, and then raise it to the power of n. And that's the same as if you took x raised to the n power, then multiply that times y raised to the n power. Now, putting the numbers in, 3 times 5 raised to the 7th power is the same as taking just the 3 raised to the 7 and multiplied by the 5 to the 7th, right? Maureen, you could also say 3 times 5, 15, and then raise 15 to the 7th. They both they would give you the same answer.
Okay.
So we call that what? The power of a product. There's the product. And there's the power. X times y is the product. That gives you the product. That's what you get when you multiply, right? And then the power is the n power. Whereas with the numbers over here, the power is the 7th. Any questions on number 4?
No.
Now, what is number 5, Maureen? What would you call this one?
The number 5.
Yes, what would you call it?
Subtract.
X over Y? No, this is not the same, Maureen. You said subtract. X, let's see, minus Y. Make that bigger.
Is add.
No. Okay, let's put 36 here. And let me put the X. Now, this is a subtraction, right? When you get the difference, that's subtraction. Okay, let's put that subtraction. Okay, now let me go addition. X plus Y. That's addition. Remember your mathematical operations, Maureen. Then if I had X, and I'll put here, I'll put an asterisk for multiplication. X times Y is multiplication. All right, and the last one is division. So I can have X, and then I'll put this over Y. So let me put this X divided by Y. And let me just make this bigger. Okay, this is this one. Actually, let's go on over to the next screen. So X divided by Y. Let's go up here. Put the Y here. Let's see, that is, okay, let's make the Y the same size. So it doesn't look like it's not proportion. Okay, so X divided by Y, and let's just bring this up a little closer so that we have, okay. So X divided by Y, which one is that, Marie? Division, right? That's division. So know the difference in your operations, right? Let's bring this. Let's see if I can bring this up a little better. Okay, there we go. X divided by Y, that's division. So notice the differences now between addition. With addition, you have, with subtraction, you have a minus, X minus Y. Addition, you have X plus Y. Multiplication, X times Y. And then division, X divided by Y. Okay, so know your operations. Subtraction gives you a difference. Addition gives you a sum. Multiplication gives you a product. And what does division give you, Maureen? What's the result of division?
A quotient.
That's right. Very good. So that's a quotient, and I'll just put these down. That's what you get when you divide. When you subtract, you get a difference. Let me put that there. Right? And when you add, you get what, Maureen?
Product.
No, that's multiplication.
Power.
No, sum. When you add, you get a sum, right?
Yeah.
And what do you get when you multiply? You just said it. A product. All right. So this is what you get. This is really, really basic. I want you to remember that. Remember the symbols for the sign, for the operation. Minus, that's a little dash, plus sign. And that multiplication, now you remember you could have a dot, you could have an asterisk, You could have an X, you could have side by side, or you could have parentheses. I chose to use the asterisk here. It kind of stands out. And you don't want, when you're using the variable X, you don't want to put another X there. It's kind of misleading. And then for the division, you can put the variable over variable, or you could have done the slash X. Let me just put this here. You could have also said
X slash
X, that's Y. That's the same thing. Okay, so you see it both ways.
Uh-huh.
All right. So number 5 is the power of a quotient because you are dividing, right? See number 5, X divided by Y, all raised to the power N.
Uh-huh.
And what's that equal to, Maureen? From this table of properties, what is X over Y raised to the N equal to? Just read it off here.
X to the Y.
No, right here.
Equal. Oh, X to the N, Y to the N.
What's this? This means what? What operation?
Division.
Division. So it's X to the N divided by what?
Y to the N.
That's right. And then when you put the numbers in it, tell me what this says.
It said divide.
What's right here?
2.
And keep going.
Divided by 3 to the power 5.
That's right. Very good. 2 divided by 3 to the power of 5. And that's the same as, what does this say right here?
Yeah, 2 to the power 5 divided by 3 to the power 5.
That's right. You can put the numerator to the power, and then you can put the denominator to the power. So you can separate them. All right. Just like we did with the multiplication. You had it within the parentheses, the multiplication, but you can also break it down and take one of the variables to the power times the other variable to the power.
Okay.
We call that the power of a quotient. So I want to make sure, Maureen, any question on the properties now?
No.
Okay, that's why I wanted to go through those, because you're not the only one missed that first problem. So I wanted to make sure you understand the properties and you can apply them. All right, now let's go back to our homework. Okay, let me bring that up. Okay, so you corrected number 1, Maureen.
And
what was your
2.
answer? Okay, so what was your answer for number 1?
Number 3.
Right, very good. Number 3, you have a power to a power. So answer 3. Very good. All right, so I'm glad you went back over it and corrected it. In fact, I'll make a note here that you had those. Let's see, I printed that. No, I didn't print it out. I think I just wrote it down. But anyway, you corrected 1 and you corrected 2. So just make a note of that, because I want to put that on your homework. Because I thought when you look it over again, you would get them correct. That's good, Maureen. It's good to go back and look over something, right?
Uh-huh.
Now, okay, that was number 1. You had that one correct. And then tell me how you did number 2.
Number 2.
What is the simplified expression of the following? 18x to the 5th power divided by 2x to the 3rd power. So what operation is that, Maureen?
Divide.
That's right. That's a division operation. So tell me how you got your answer.
I subtract the 3 from the 5.
Okay.
But, and then I divide the 18 by 2.
Okay. So you can do it either way you want. You can do the powers first and then the division, or you can do the division first. Okay. So you took 3 from 5 and you got a 2. And then you divide 18 by 2 and you got what?
9.
9. So your answer is what?
C.
Okay. Answer C. Okay, so I'll write what you said. You divided 18 by 9 and subtracted
No,
uh
no, 18 from 2 from 18.
okay, no, you
So,
divided 18 by
yeah,
2 and you
yeah,
subtracted 3 from 5 for the powers. Okay, so you had two operations here. One was your whole numbers 18 and 2, and the other was your power. And since it was a division, we can look right over here, and what does it say? X to the n over x to the m is numerator power minus denominator power. And that's what you did. Numerator power 5 minus denominator power 3. All right. Now, Maureen, you had this one. Did you have this one correct?
Which one?
I think you did. Number 3.
I do number 3.
Yeah, I think you had number 3 correct. Let me,
Yeah.
yeah, let me look at, I recorded it here. After you sent it to me, I recorded it. Okay, so let me, okay. Okay, so Maureen, you had number 3 correct. All right. So let's go through number 3. I want you to tell me how you did number 3. I'm going to the next screen, the next, so we can put it all on one screen. Okay, Maureen, how did you do number 3? Simplify square root of 72. So tell me what you did.
I do 12 and 2. And then
You did what?
okay.
What?
I said the square root of 72, right?
Right, and you broke that into 2 radicals. What 2
Right.
radicals did you put here?
Yeah.
What 2 radicals?
I get, let me see, 12. How do I get 12, right? Let's see, and 6. And then
Neat.
I break it down. Oh, you said 65, right?
Okay, so you did 12 and 6. Okay, let's do it this way, Maureen. You did 12.
Okay.
Okay, no. You got your answer with 12 and 6, you said, right? So okay, let's do it the way you said it, because there's always more than one way of doing a problem. So you made this, let me just put here. You made this a 12 and then a square root of 6, right? So let's just put that there and put this here. So this is what you did, square root of 12 times square root of 6.
I can't remember how to do one, but I can't
Is
remember how to do one.
okay.
I know I use 12.
Well, if you use 12, factors of 72 are 12 and 6. 6 times 12 is 72. What did you do from here?
What I do? I don't even know what I do. I can't remember.
Okay, Maureen, let's go back. Okay, let's go back. Now, let's just take 72. Let me just go over here. Let me just take 72. Now, give me 2 factors of 72 where 1 is a perfect square. What would that be?
Yeah.
72 is what 2 numbers multiplied where 1 is a perfect square?
One is 6 12s.
12 is not a perfect square root.
I know.
2 numbers you can multiply and get 72, and 1 is a perfect square root.
Okay. 72.
One.
Yeah.
Think of half.
36.
Yep, 36. And that has a perfect square root, right? Times what, Maureen?
2.
That's it. Okay. So 36 has a perfect square root. That means you can take this square root of 72. Let's just put this here. Put this on the next line. And let's just factor that into 2 square roots. And that would be, okay, you told me 36. Let's just put 36. And that would be times square root of 2. So let's just put the 2 here. There we go. Just like you factored that 72 into the numbers 36 and 2, you can factor the square root of 72 into square root of 36 times square root of 2. Now,
6 and 2.
that's right, Maureen. Then you get square root of 36, perfect square root, right? So let's just put that here. And that would just be the 6. So we just take that out. Take out the radical symbol. So now that's our answer. 6 times the square root of 2. And that's answer what, Maureen?
C.
Answer C. And you had that one correct. Okay. So what you could do when you're doing these, think of the factors without the radicals, then put them under the radical symbol, and then you can get, and always think perfect square root. I gave you a list of them, right? Perfect squares.
Yeah.
Do you use that list?
No.
Well, when you don't, well, you probably know a lot of them. You don't have to use it, but when you don't, use the list.
Uh,
All right.
okay.
Okay, so you had number 3 correct. You also had number 4 correct. Factor 6 times square root of 40. So Maureen, can you tell me how you did that one? You had it correct.
I just guess.
Oh, you guess.
Yeah.
Well, you made a good guess, but let's just write how you do it. Okay. So 6 times square root of 40. Okay. Now, what are factors of 40?
Well, factor 40 is 1, 2.
No, just give me 2 numbers you can multiply and get 40.
Oh,
One with the perfect square root.
perfect square root.
40 breaks down into 2 numbers.
20. It's not a perfect square root. No.
That's right. Think of 2 numbers you can multiply and get 40, and one has a perfect square root.
10 fours is 40. Right?
Okay, 4 times 4 times 10. Very good, because 10 is a perfect square root, right?
Yeah.
Okay, so we can then say 6. Let's take 6 times square root of 40. Let's rewrite that. Okay, and then we'll break down our 40 into what? Square root of 4. Let's take that out. And let's put times the square root of 10. So let's just take this, copy it. Okay, and this would be 10. So what we did, we took the 6 stays just where it is. That's the coefficient. We broke 40 up into 2 radicals, square root of 4 times square root of 10, because 40 factors into 4 times 10. Now, what is the square root of 4, Maureen?
2.
Okay, so this becomes, let's just rewrite this and put our square root of 4 that you just told me is 2. So let's just put that there. Square root of 4 is 2. So let's just put, and I'll just put parentheses here. Right? That's a 2. All right. So we have 6 times 2 times the square root of 10. What is that equal to, Maureen?
12, the square root of 10.
That's it. Very good. So 6 times 2 multiplies to give you 12. All right. So 12 times the square root of 10, and that's your answer. And what letter is that, Maureen?
D.
D, that's right. Answer D. Okay, very good. Now, you guessed, but sometimes you guess and it's not correct. So it's best to know how to do it. But it's like,
No.
yeah, you want to factor the number into two numbers, one with a perfect square root. Now, when you pick 2 and you say, oh, they're not perfect square roots, now you can actually get some that's not perfect square root, but you end up taking more steps to do it, right?
No.
So you're better off if you can think of 2 numbers, one with a perfect square root, then you like halfway there, okay?
Hmm.
But since you had a 6 here, you had to multiply that 6 by what you got for the square root of 4.
Mhm.
Now, the next one, Maureen, let's see, that was what, number 4? This is number 5. I don't think, did you do,
You said you said I had 5 rounds.
yes, you had 5 wrong, and I wanted you to tell me why did you put what you put, okay? Because you had A.
Yeah.
All right, so let's just put this all on the next screen.
The thing that you got there, like number C, you got the espresso N is in simplify form, right? That way you can understand anyhow.
Expression is in simplest form.
Yeah.
That means it's already simplified. You can't go any
Oh,
further.
oh,
When it's in simplest form already, then you just leave it like it is.
oh,
In other words, if you can't break this down into factors
uh,
to make it simpler, then it's
oh, I see.
already in simplest form.
Oh,
Now, okay, so you said your answer was A, Maureen.
yeah. But
Oh,
then I correct it and I put C.
okay, all
Yeah,
right.
but I didn't know C was right
C
nice.
is correct. C is correct. Now you put A, but see, 21 does not factor into 7 times square root of 3, but it does factor into square root of 7, right, times square root of 3. So it factors in square root of 7. Let's just put that there. Okay, 7. And let's just put here. And this is square root of 3.
What I was gonna write, I was gonna write and send it out to you and say like know something. So I was gonna write to tell that five was like I wasn't gonna write A, B, and C. I was gonna write just as no I can't remember the word now. Yeah.
What? No factors?
No,
No
it begins with
factors.
S.
Yeah. Well, when you factor square root of 21,
Uh,
now that factors into 2 radicals. Now, A
uh,
doesn't have square root of 7. It just has 7.
right.
So that can't be. All right. 3 is by itself, it has to be a square root. Remember when we take a radical and we factor into 2 radicals.
Uh,
So square root of 21 factors into square root of 7 times square root of 3. But what do we know about 7 and 3, Maureen?
7 and 3 is 10.
No. What can 7 or 3 be factored in something else other than
No,
1? Okay,
definitely one.
so 7 and 3 are what we call prime
Prime
numbers.
numbers.
They're prime numbers. In other words, they can't factor into anything other than themselves and 1. So when you get prime numbers as in your radicals factors, then that means the factor is the radical is in its simplest form. So your answer would be C. Okay. So
Right.
what you do is you take the radical. When I say radical, I'm referring to the radical and the number, because this is a radical symbol. 21 is called a radicand, but I refer to the whole thing as radical, right? So this is a radical. 21 factors into 2 radicals, 7 and 3. All right. But both of these are prime numbers. You cannot factor these any further other than 7 times 1 and 3 times 1. When that happens, then your radical is already in its simplest form. You got it, Maureen?
Yeah.
Okay. Now, let me give you another one. See if, okay. Suppose you had, okay. 24. What does that factor into, Maureen? What does 24 factor into?
Let's see. 1, 2, 24. Like, listen,
Give me 2 factors, 1 a perfect square root.
6 and 4.
Yeah, that's right. So 4, that's the one with the perfect square root, right? And that would be 6. Okay. Now, what's the square root of 4?
2.
Okay, so let's just put 2. So the square root of 4 is 2, so that's 2. Now, 6 has factors, right? But what are the factors of 6?
2 and 3.
What?
2 and 3.
2 and 3, but both of those are prime. So you don't have to go any further than this. Got it?
Yeah.
See, that's another example where it's not in its simplest form, but what you got, the 6 here, factors in the 3 and 2, but they are prime numbers. So that means 2 times square root of 6 is just the expression you get when you factor 24. All right. Now, what if you had, okay. What if you had, let's see, give you another one, 37. And I gave you choices and one was in its simplest form. Which one would you select, Maureen? I gave you,
37.
yeah, so multiple choice, and I gave you choices. One of the choices, the expression is in its simplest form. What would you pick?
The same 37.
What would you say? Can square root of 37 be factored into 2 factors, 1 with the perfect square root?
Oh, I see.
In other words, what I'm asking you, is this expression already in its simplest form?
I think so.
Yes, you're absolutely right.
Yeah, because
It's
Yeah.
Why, Maureen?
I know. They would say like, okay,
Why
because
is
that don't because that don't, 37 is not is a prime number anyhow.
37
So
what?
37 is a prime number. So if you
That's
put
right.
like
37 is a prime number. So it can't factor into anything else other than 37 and 1, right?
yeah,
And since it's a prime number, just like with the 6, we got a 2 and a 3. Those are prime numbers. So
uh-huh.
37 is simplest form because it is a prime number. So when you have a number that's a prime number, just like the 21 only factored into 21 and 1. So you could have said, okay, 21 only factors into 20. Well, it factors into 7 and 3, actually, but those are prime numbers. But but the 37 is different because it only factors into 37 and 1. So
Uh-huh.
it's already a prime number. Okay, so you know how to determine if you have a prime number, all right? It could be factors of your radical, or it could be just a radical itself. Like this one, the radical itself is a prime number. 21, its factors are prime numbers. Got it? Questions, Maureen, on that one?
No,
Okay, now let's go to number 6. Number 6, you had correct, Maureen. So tell me how you did number 6.
I do. See, I do 44 and 2, but then that can be 44.
What did you do?
Let's see. Look at it. Okay, two numbers that could go into 88, right?
Oh, two. Okay, let's put here. All right. Now let's put 88. What are the factors you use for 88? What did you factor that into?
I use 22
Okay, and what?
and 4.
Okay, very good. 4 times 22. Because what? 4 is a perfect square root, right?
Yeah.
So let's just take the 3 times square root of 88. Okay, so that's equal to, okay, so that's 3. And so this will be times the square root of 4. Let's just put square root of 4. And times square root of 22. And we don't have a 3 here. Okay, now what's the square root of 4, Maureen?
2.
Okay, that's just 1, 3. Okay, so that's 2. So let's just copy that again. Let's just take this 3 times square root of 4 times square root of 22. Copy it. Square root of 4 is a 2. So let's
Mm-hmm.
just put parentheses 2. And what's 3 times 2, Maureen?
6.
6. So 6 times square root of 22. And that's answer what?
D.
D. And you had that one correct. Very good. So 6 times the square root of 22. And that's answer D. Okay, let's put our answer here. Okay, answer D. Okay. Maureen, any questions now on the radicals factoring?
No, I think I got a clue.
You think you got it? Simplifying and factoring of radicals. No questions? You said no?
No.
Okay. So you said no questions. I will
Hi.
give you one to practice on.
Good afternoon, everyone.
Hello,
Nothing,
Chastity.
Chastity.
Hi. I'm just,
Okay.
always doing something, that Miss Barbara, but I'm listening.
Okay, very good. All right. So, Maureen, I want you to do this. Okay, let's see if I want you to simplify.
I'm sorry. I was gonna say something.
Yes, go ahead.
I forgot about what a prime number is.
Okay, Maureen, what's the prime number?
A number that could go into itself one time.
Yeah,
One time?
it's a number whose only factors are itself and one. In other words, give her an example, Maureen, of a prime number.
1, 3, 5, 7.
One
And
and
that
what?
goes 1, 3, 5, 7.
Okay, she's giving you some examples because 5 factors only into 5 times 1, Chastity.
Yeah.
7.
9 also, right?
No,
Is it?
9 is 3 times
No.
3, right?
Oh, okay.
Okay, 7 times 1, right? So you can't factor 7 into anything else. Maureen said also what? What else you said, Maureen? 5
Mhm.
7.
equal 5 times 1.
Okay.
All right. Chastity, what about 21? Is that a prime number?
Is that a prime number?
Yes.
No,
Why?
because 7 times 7 is 21. No.
7 times what?
No.
7 times what?
7 times 3.
That's right. So it factors into other than 21 times 1, right?
Yeah.
Okay. What about 29? Prime or not? Chastity?
Not.
It's not a prime number? What does it factor into?
I'm not sure about that one.
Maureen, what does 29 factor into?
And so it says,
Yeah, just 29 times 1. So it's prime.
Oh, okay.
All right.
Got it now.
You got it now? When you can break it down into 2 numbers, Chastity, and it's just the number itself and 1, then it's prime. But if you have some other numbers like you did with 21, it's not prime. 21
Okay.
is not prime. All right.
Thank you so much. Yeah.
Okay.
Thank you.
So now you know the difference. But now I want you to simplify. Let me see what I want you to simplify. Since you didn't have any questions, that means you are ready to practice some, right? So let's go to, and I'll put this on the next screen. Okay, Maureen, I want you to simplify. Okay. And let me give you this one. Okay, 8. And let me put a square root here.
I'm gonna be driving off soon, okay?
Okay, all right. So 8 times the square root of, okay, Maureen, 8 times the square root of 36. Maureen, you ready to simplify that one?
oh, that is, you can't simplify that because it can go into 36.
This is not a division.
Uh,
This is a coefficient 8 in front of square root of 36.
yeah.
Square root of 36 has a perfect square root, right? What is
Yeah.
it? Yeah, so what's the square root of,
6.
so what's the answer?
6. Add square root 6. Right?
Okay, so let me put here, okay. Square root of 36 is 6, so let's put,
Yeah.
the 6 here. So what's the answer?
Add square root 6.
No, you said the square root of 36 was 6. What's,
Yeah.
so we put the 6. So what's 8 times 6, Maureen?
Or 48.
48.
Mm.
So you can, I'm showing you this so you can see you can get
Oh.
a number when you
Uh-huh.
simplify, because
Oh.
this square root of 36 is a 6, and then when you multiply it by 8, you get the number 48.
Oh.
So that's the simplification of 8 times square root of 36. You told me square root of 36 is a 6. Multiply that by the 8, you get
Oh.
48.
Oh.
Got it?
Oh yeah.
So I want you to know when you simplify, you don't always get a radical. You could get a
Oh.
number.
Uh-huh.
Okay. Try another one. This is still simplifying. All right. Try simplifying 2. And let me put a square root here. And let's see. Let's make this 100. What would that be, Maureen? 2 times the square root of 100.
50.
Hmm?
50. And then
Wait.
you went by that's the simplest, right?
So what are factors of 100?
Let's see. 25 on 4.
Is 100 a perfect square root? Is that a perfect
Yeah.
square? Okay, so what's the square root of 100?
10.
Okay, so this then becomes, okay, so that would be
Oh, I
2,
see.
you see,
Yeah.
times 10, and the
Equals to
answer is what?
20.
20. Another one with
Oh,
a
I see.
number.
Oh yeah. I
Okay.
forget that already.
Yes, I know. I know. That's why I put another one in there. So you understand that sometimes you simplify to a number because you know the square root of 100 is a 10.
Yeah.
Okay. All right. Let's try another one. All right. Let's see. You want to simplify. I gave you 2 times square root of 100. Okay. Okay. Let's make this one 6 times the square root of, let's say, 90. 98. Okay, Maureen.
Okay.
Tell me the answer for that one.
Let me see. 49. Right?
The answer.
Okay, the answer is square root of 49. That's 98. It's 42 or 49. 49, right?
Yeah, the square root of, okay, so let's just copy this again and put what you're just telling me. 6 times the square root of 98. Let's put that there. And the 98 factors into square root of 49 that you said.
Yeah.
And this is also a square root of 2, right? So let's put the 2. Square root of 49 times the square root of 2. So that's the way it will look, right?
Yeah.
Square root of 98 factors in square root of 49 times square root of 2. Now, what's my next step, Maureen?
Then you multiply the 2 by the 6.
No. What's the square root of 49?
2 and 7. 7.
It's 7. Okay, so let's just copy this. All right. And the square root of 49, you just told me that's a 7.
Yeah.
So let's
Yeah.
just put in parentheses 7. That's the square root of 49. Square root of 2 stays the same. Now, what's
Yeah.
the answer, Maureen?
The answer is, let's see,
What's 6 times 7?
or 6 times 7 is 42.
Okay, 6 times 7, you got 42.
And the
And
square root of 2.
that's it. That's your answer. All right, you got it?
Uh-huh.
Okay. So once you break it down into the two radicals, then
Mhm.
get the one that would have the okay, so this is the answer. All right.
Uh-huh.
Got it, Maureen? So once
Yeah.
you pick a perfect square root, you take the square root of that, and if you had another coefficient, you multiply it by that coefficient, and then the square root of 2, that's a prime number. We just leave that the way it is. Got it?
Uh-huh.
Okay. So, all right, let's go to, now I wanted to look at some, okay. Okay, before we look at the scientific notation, let's go to, okay, number 8. Anything raised to a power of 0 is always what?
1.
1. Okay, you had that one correct. So answer B. That's right. Anything raised to it could be a constant, it could be a number, but anything raised to a power of 0 is always 1. Now, number 9, Maureen, you didn't answer that one. I wonder why.
No, I couldn't understand that one.
Okay. Now, the rule of exponents. Whenever you have an exponent to the negative power, it's reciprocal of the positive, right? In other words, 3 to the minus 4, let's just put that here. And when I say it's reciprocal, you just turn it upside down, actually. So let's just put 3 to the minus 4. And this is really over 1, even though we don't put it there, but it's understood to be over 1. That doesn't change the value of it, right? So this would be 1. Now, whenever you have a negative exponent, you take the reciprocal. In other words, you flip it and then make it positive. So this would become what, Maureen? If I turn this upside down, what do I get?
We get 1 over 3
Okay, that's right, I get 1
over 3
over 3.
and the 4 by the 3.
So I get 1 over 3, and then the minus 4 becomes what? I changed the sign now. 3, this would be, okay, let me take this. Let me take out this underline right here. I don't want that. Okay, Maureen. 3 to the minus 4 over 1, flip it. The 1 is now in the numerator, the 3 is in the denominator, but then you change the sign of the 4. So what does this become?
A 4.
That's it. Very good. 1 over 3 to the positive 4. So what's the answer?
Yeah.
That's right. Answer is A.
Remember the chairs?
Yeah.
Okay.
Got it, Maureen?
Yeah, I figured that out too, but then I sang and words that hurt my head with it.
What happened?
I thought I had figured out that, but I didn't write it because I figured it was wrong.
Okay, so the answer is A. 3 to the minus 4 is 1 over 3 to the positive 4. So all you do is just flip it. The numerator, this is the denominator 1. That becomes a numerator. And the minus 4 becomes a plus 4. And you don't have to put a plus here. That's the default. So the answer is A.
Support with a plus. Support with a plus sign. How it will work?
If you put a plus sign,
Yeah, instead of 3 minus 4, they put 3 plus 3, like plus to the power 4.
well, 3 to the 4 would just be 3 to the 4.
Oh, I see. Okay.
It's only with the negative that you flip it.
Oh, I see. All right. Okay.
So it would just be like B, 3 to the 4.
Okay.
Okay. But if you have a negative, you make it a reciprocal of the positive. In other words, flip it where the numerator becomes the denominator becomes the numerator, but the sign changes. See, once you flip it, the sign changes. Okay. Got it?
Yeah.
Just like if you had 1 over 3 to the 4 and you flip this, then 3 to the 4, then that sign changes to minus 4, which is what we had here. Okay. That's one of your exponent rules. Your negative exponents or the reciprocal of the positive exponent. Or just think of it, if you don't want to say reciprocal, just think of taking the negative over and you just put it the exponent negative power over 1 and then just flip it to 1 over the this is the power and this is the base. So just flip it where the base is now the denominator and then the power changes from negative to positive. Got it?
Yeah.
Okay, now I wanted to get into let's just now I didn't go too much into this decimal notation, and I really didn't grade you on that. I mean, just want to see how you did, but let's just look at scientific notation. Now, remember I said you could have number expressed 10 times 10 to the positive or 10 to the negative. But just remember, if your number is less than 1, you'll always have a negative exponent, like this 0.077. But if the number is 1 or greater, you're going to have a positive exponent. So, and the number is always between 1 and 10. In other words, the number, you wouldn't, let's just take 20.3. Now, you want to express this in scientific notation. So your decimal point is here. Maureen, where would you put the decimal point?
In front of the 3?
It's already in front of the 3.
The other side was
As scientific notation, where would I put it? I would put it between the 2 and the 0. Okay, so that would be 2.03 times 10, and the power on the 10 is the number of places I moved the decimal point. So how many places did I move my decimal point?
Okay, hold on. 2 places?
It's right here. And I moved it here. How many places is that?
1 place?
1 place. So that means I put a 1 for my power. Got it?
Yeah,
And since I'm moving it to the left, the power is positive. If I were moving to the right, the power would be negative.
Okay.
So that would be the answer for 20.3.
Okay, so the number 2, okay, with the 49, you will move it to the right.
No, you're moving it to the left. So your big numbers that's greater than 1, you always moving to the left. So the 49,000, let's just put that here. Your decimal point is really right here, right?
Uh,
If you don't see it, it's after the last digit. So it's right there. So how many places are you gonna move it, Maureen? You're moving to the left.
the
Move it.
last would be like
What
places.
what would be the number you get? Now it has to be less than 10. So where would you move it? Between what 2 digits?
The 49.
That's right. Very good. So you move it between the 4 and the 9. And there's always time the base 10. And how many places did you move it?
4 places.
That's it. Very good. You moved it 4 places. So then you put the decimal, you put the power 4. Got it?
I think so.
So notice I moved here to the left, positive power. I moved here. I'm sorry. I moved here to the left. I'm positive, right? I moved here to the left and I have positive. But now if I go to 0.077, I'm moving my decimal point to the right. So let's just put that on there. Okay, Maureen, what would that be equal to?
Okay, you put it to the right, right?
Yes.
So you will put it, I don't, let me see.
So if I move it to the right, where would the decimal point be now? It's right here.
In front the 7?
Which 7?
It's 2 sevens in between the 7s.
In between the 7s. That's right. Very good. In between the 7s, so that's 7.7. Always times the base 10. And how many places did I move it?
2 places.
2 places. And it's to the right, so it'll be positive or negative.
Negative.
That's it. Very good. So that would be -2.
Oh, I see.
Got it, Maureen? Okay. Now, let's just practice a couple. I wanted to go through the rationalization, but I wanted others to be on for that. But okay, let me just go here and then let you practice on another one. Suppose you had 1, 5, 5. Let's see. Comma 6. Okay. Maureen, what would that be equal to? Where would you move your decimal point? Remember, your decimal point is right here. So put the number between what number less than 10. So what would be the number in front of the times 10?
Move it in front of the, in between the 2 5s.
No, between the two 5 would be 15.5. Remember, it's got to be less than 10.
Less than 10. So in between the 1.
That's right.
And the 5.
That's it. Very good. 1.5 and 5, 6 and times 10. Now you moved it how many places, Maureen?
Okay, let's see.
Since you're moving it to the left, you know it's going to be positive. You could just count the digits, really. 1, 2, 3, 4, 5. So it's 5, right?
1, 2, 3, 4, 5, yeah.
So to the 5th place. That's it. You got it, Maureen. You put the number, and remember it's less than 10. So when you said 5th between the 2 5s, that would have been 15.5. That's greater than 10. It's got to be less than 10.
I see.
Okay. And so once you put it there, then you just write the 5, 5, 6.
Okay.
You don't have to put the zeros there. Okay. And you moved it 5 places. So it's time 10 to the 5th. Okay. Try another one. Suppose you had 8754. Okay, Maureen. 87. I'll just put the comma there. Okay. What does that equal to, Maureen? Give me the number first. Less than
Okay.
10.
Less than 10.
Mhm. So where would
If
the
we-
decimal point go?
In between the 8 and the 7.
Very good. 8.754. And then times the base 10. How many places did you move it?
3.
3. That's right. Just say 1, 2, 3. Just look at the numbers. Okay. So that's 3. Maureen, you got it. Very good.
Hi, good afternoon, Barbara.
Hello, Mercedes.
I am so late. I was out.
Yeah.
Yeah, no
Okay.
problem, Mercy. You're still there.
Hi, Mercy.
Yeah, we're
But
doing scientific notation, and Maureen is really doing really well on this. So Mercedes,
I'm sorry about the work, miss.
did-
No
Sorry.
problem.
okay. So let's just take another one. Okay. 3, 2, 6, 7, 0, 0, 0. Okay.
Oh, but that's a big number.
Yeah, I'm giving you a big number. So okay.
3, 2, 6.
Okay,
7,
Maureen, tell me what this one would be.
and 3 zeros, right?
Yep. So what would the, given the number first, less than 10,
7.
where would your decimal point go?
In between the 6 and the 7.
No, that would be
Oh.
326. Remember, it's got to be less than 10.
Oh. In between the 3 and the 2.
That's it. Very good. Between the
Oh,
3 and the
it's
2.
less than 10.
You got
yeah.
it. It got to be less than 10. So 3.267 times 10. How many places did you move it? Just count.
6.
6. That's right. So you move this to the left, positive exponent. So that would be 6. Mercedes, are you understanding this? Mercedes, you're on mute.
Oh, sorry.
Are you understanding the scientific notation?
Why, does she count from the 10? Why she got 6 places?
Well, Maureen, tell her where you counted from.
I counted from in front, the first 0 went backward. So
Yeah.
1, 2, 3.
Well, your decimal point is right there. So
Okay.
tell her how you counted, Maureen.
I count from 1, 0, and then put it into between 3 and 2.
Yeah.
So it would be, it'd be 6
You count
numbers.
the spaces are between the 0, 1.
Well, you can just count the digits. 3 and 3 are 6. To
6.
get you between the
Oh.
3 and the 2.
Yeah.
Oh,
And since you move into the left, it'll be a positive power.
so you have to put 10 to the 6th power.
That's it, because that's the 6 power. 6 represent the number of places you move the decimal point.
Just like how you do the 5 up the top, there and the 3.
Yeah.
Thank you.
You got it?
Yes.
Okay, now let's take some numbers less than 1 where you're moving the decimal point to the right. Now, 0.00
You're going right now.
67.
0,
Okay, Maureen, what is that one equal to?
6, 7. How much zeros? 3 zeros?
Yes.
Okay.
So your decimal point, you move it between what digits?
6, 7.
So what?
Between, you're doing it right now, right?
You're moving to the right. That's correct.
Okay.
So where would the decimal point go?
between the 6 and the 7.
Very good. So that would be 6.7. That's right. That satisfies your less than 10 rule. How many places did you move it?
4.
4. Plus or minus on the power?
A minus on the power.
That's right. Minus 4. Mercedes, you got it?
So Miss, what indication will you get? You give us an indication to know where to move left or right?
Well, if your number is less than 1, like this number, it's less than 1, right?
Yeah.
You're going to move from this point to this point. All right.
So wait a minute, Miss. What number left less than 1? The
Point,
zeros?
no, 0.0067. Isn't that less than 1?
I don't understand the question. When you say less than 1.
Less than the number 1 isn't. How would you say this in words?
You mean that?
This.
I would 67 6 tens and 7 ones.
No, how would
Wrong?
you say it in words? This is tens, hundreds, thousands, tens of thousands, hundreds of thousands. So this is 6,700 thousandths.
Oh,
All right, so that's less than 1. All right,
10,000s mean less than 1. I'm sorry, I'm not
you,
gravitating.
you know your place value.
I'm sorry, I remember them.
Maureen, you know place values?
Yeah, I can't remember. Yeah.
Yeah, so you have a whole number 1, and just think fractions, except we have it as decimal. So this number is really 67, let's see,
One of-
tens, hundreds, thousand, tens of thousand, hundreds of thousand. So that number, and let me just write it, what it really is 67 over tens, hundreds, thousand, tens of thousand, 100,000. So that's 100. That's 67 over 100,000. That's a fraction less than the whole number 1. Sadie, did you follow?
I'm trying to. I'm sorry.
Okay. When I say 1, okay, let me put here 1. 1 is any number over itself, right? Like
Okay.
10 over 10, 100,000 over 100,000, a million over a million, a
Okay.
100 over 100, right?
Okay.
But if I have a fraction where my numerator is a lot smaller than my denominator, then I have a fraction that's less than 1. Except this is a big fraction, 67 over 100,000. So when I say less than the whole number 1, that means all fractions less than the whole number 1.
Like what you have 10 over 10.
What was that question?
Like how you have 10 over 10.
Yeah, but that's 1. Any number over itself is 1. But if I had 10 over 100, that's like 1/10. That's less than 1, right?
Okay.
If I had 10 over 100, that's equal to 1 over 10. All right, that's less than 1 over 10. Like if you had 10 cents, you've got less than $1, right?
Yes.
Put it like money, right? $1 is a 1. If I have 10 cents, I have less than $1.
Yeah.
So if I have a fraction of that value, then it's less than the whole number 1. So this 0.0067 is a number less than the whole number 1. Got it?
I think so.
Okay, so
I think I go up to it.
okay, so Maureen gave me this one. All right, Mercedes. Now let me give you one here. suppose you had, you writing this as scientific notation, 0.0, let's see, decimal point 0.00254. What would that be equal to in scientific notation? Mercedes.
Let's see. 4. The point go between 5 and 4.
No, the number you give me to multiply by the 10 has got to be less than 10. 25.4 is greater than 10. So where would I move my decimal point? It's right here. Where would I move it?
Okay, between the 2 and the 5.
That's right. Very good. Between the 2 and the 5. So that becomes 2.54 times 10. And I moved it to the right. So my decimal point would be negative. What would be my decimal point? I'm sorry, by power.
Your power would be 3
Plus or minus?
plus.
No. Whenever you move into the right, it's negative.
Okay.
You're moving here, negative. So that would be a -3. Well, a 10 to the -3 is 1/10 to the third, right? So that's 1/100. So 2.54, because this is really what? 2.54 over 100, or 254 over 10, 100,000, tens of thousands, 100,000.
Okay.
So your decimal point is here, and you must have a number less than 10. So that's why you couldn't put it here, but I'll say this. That's why you wouldn't put 25.4, because 25 is greater than 10. But if you put between 2 and 5, 2.54 is less than 10.
Oh.
So number,
Oh,
you got
that's
it?
why the one that's why the one that Maureen did. You put it between 6 and 7 because
That's right, because she didn't put it right here, because that would be 67.
okay.
And you can't put it here between 5 and 4, because that would be 25.4. So first step, number less than 10, then times 10, and then the power is either plus or minus. It's
Yep.
minus if you move right, it's plus if you move left. The power is equal to the number of places you move the decimal point.
Okay.
Got it?
Thank you, Miss.
Okay. Now,
Got it, sir.
Mercedes, I want you to do another one. Okay. Suppose I gave you 8, 6, 7, 5. And I want you to write, okay, I just put a comma here, you know. So 8,675. Tell me what would that be in scientific notation? What would that be, Mercedes? First, give me the number less than 10.
Okay. Is that between 6 and 7? No.
That would be 86. Remember, it's got to be less than 10.
Oh, so I can go to that side too?
No, the number you multiply times 10 to a power has to be a number less than 10. Your decimal point is right here after the 5. Where would you move it to get a number less than 10?
So I will start moving it from behind the 8. 1, 2.
So it'd be 8.6, right? 8.675, because that's less than 10, right?
Okay.
Times, always times base 10. How many places did you move it?
3.
You moved it because you were here. So you move 1, 2, 3, or count 1, 2, 3. Okay, so this will be what? Positive power, because you moved it to the left. I'm
Excuse me.
sorry. That would be 3. And 10 to the, well, 10 to the third is 10 times 10 times 10 is 1,000. 8.675 times 1,000 gives you 8,675. You see that, right?
Mhm.
Because 10 to the 0 means 10 times itself 3 times. That's 1,000. 1,000 times 8.675 gives you 8,675. Got it?
Okay. Yeah, I'm trying to get it. I'm getting it.
So you're saying that everything that we do here is less,
Yeah.
they got everything less than 10. No, these things we do today.
Okay.
Well, what did you say, Maureen?
Like all these things have to be like less than 10, right?
Yeah, the number in front of the 10 to a power has to be less than 10.
Okay, yeah, I understand.
Okay, so that
So the next time I
determines.
get anything to do, I will know what to do. Yeah, but I can figure it out.
That's right. Yes, it's got to be less than 10. And then
But
the
I jot,
next,
yeah.
go ahead, Maureen.
But I jot down all my notes in case if you get any again, I can turn back to their notes and figure it out myself. Yeah.
Okay, all right, all right. So let's just take another one. Okay, 0.000097. Mercedes, what would that one be?
Put the point between the 9 and the 7.
That's it. Very good. 9.7. And then always times the 10. How many places did you move it?
5 places.
How many?
One check. 5 places.
5 places, plus or minus.
Minus.
Minus. Very good, Mercedes. You got it.
Thank you.
Okay. Because you move to the right, you know, this negative, and like I say, this is less, this number is less than 1. Any questions on scientific notation?
Not yet.
Okay. All right. Now I want to go through, let me do new share. And I want to go to, now there's one other thing I wanted to do here. I want to go to something called rationalizing radicals. Okay. Rationalizing radicals. That's over on the right side. Now, all that is doing is if we have a radical in the denominator, we want to rewrite it. Now, rationalizing, that means, you remember when we went through rational numbers? You remember what we said a rational number was, Maureen?
I don't think so.
Okay, rational numbers are numbers that get written as A over B.
Oh, yeah.
Okay. Like irrational numbers, a really popular one is the number pi, because that's like 3.1416, et cetera, and it cannot be written as A over B. Okay, so when we rationalize a denominator, we want to change it from a radical to a rational number, and the way we do that is to multiply the radical by a radical. All right. Now, can you see this, or should I make it bigger? Maureen, can you see?
Yeah, I can see it.
Can you see it? Okay. Let's make it a little bigger. Okay. Okay. So what we will be doing is rationalizing radicals in our denominator. Okay. Now, example, 2 over square root of 5. Now, what we do is we multiply the radical by itself, both numerator and denominator. And the reason we can do that, because if we take square root of 5 over square root of 5, that's the same as 1, right? And we can multiply by 1. So remember what I told you, the power on the square root? What's the power, Maureen? You remember?
Power on the square root.
Yes. Remember what I said? It's really to the 1/2. Square root is really to the 1/2. So square root Or another way to remember is just whenever you multiply a radical by a radical, you just get back just the number itself. In other words, square root of 5 times square root of 5 just gives you the number 5. Got it?
Oh,
So if I multiply both my numerator and my denominator by square root of 5, in the numerator, I get 2 times square root of 5. In the denominator, I just get the number 5. Square root of 5 times square root of 5 is just the number itself. So when you rationalize this, your answer would be 2 times square root of 5 over 5. Any questions on that sample?
So you're saying, Miss, that instead of putting it as 5 to the 5th power, just put the 2 and the 5 over 5.
Well, this is not 5 to the 5th power. Square root of 5 is not, square root of 5 is saying what number time itself gives you 5, but the square root of 5 is not a perfect square. So what
you're
I'm,
saying,
go ahead.
sorry, you're saying if you say 5, 5, 25, instead of putting 25, you just put 5 there.
No, that's not what I'm saying.
Oh, I'm sorry.
Okay. Here's what I'm saying. Rationalize 2 over square root of 5. That's what the problem will say. Rationalize 2 over square root of 5. Now, remember I said we want to rationalize our denominator. The denominator is square root of 5. So the
Okay.
way we do that is we multiply this expression by square root of 5 over square root of 5. In other words, multiply the numerator by square root of 5, multiply the denominator by square root of 5. That's like multiply by 1, and that's permissible. Okay? Square root of 5 over square root of 5 is equal to 1. What happens in the numerator? 2 times square root of 5. Denominator, square root of 5 times square root of 5 gives you the number 5. And you can just remember that as a rule. When you multiply a square root times itself, you get back just what's under the radical. In other words, a radicand.
Okay.
You got it? So this 2 times square root of 5 remains as it is. The denominator is now 5. So your answer is 2 times square root of 5 divided by 5. That's the rationalization of 2 over square root of 5. So just think of it as taking the radical in the denominator and making it a rational number.
Okay.
And you can do that by multiplying the radical by itself in both the numerator and the denominator. You multiply it by itself in the denominator and then multiply it by whatever's in the numerator. Questions?
I have to keep studying this, Miss, until I kick it.
Well, no, I have some, okay. So I gave you the steps here.
Oh,
So when you rationalize denominators, write them as 2 separate square roots. Multiply by 1, that means the radical over the radical. And then you can simplify the answer, okay? And this makes more sense when you practice, okay? Now, look at this first practice. Now, what radical do you see in the denominator? Let me just put this on the next screen. Okay. Now, Maureen, what radical do you see in the denominator?
3,
Radical.
2.
The square root of 2 is a radical you see in the denominator, right? So we want to rationalize this expression. So we have 3 and we have 2 times square root of 2. So you can write them as 2 separate square roots. Okay, so we could say 3. Let's take the 3. Let's write them separate until you really. Okay, so this would be 3. I'll put this 3 here. All right, now I will multiply this by square root of 2 because that's what we want to rationalize this. Okay, so let's put 3 times square root of 2, right? And then I'll take this 2 times square root of 2, put it here, okay? And I multiply 3 times square root of 2, 2 times, and I multiply this also by square root of 2, right? So I'm gonna just put this in parentheses and put the square root of 2 here. So that's really multiplying by 1, right? So I have 3 times square root of 2 and 2 times square root of 2. Let me just put, I don't want to put this underlinage because I want to do it as separate steps. Okay, so 3 times the square root of 2, we just leave it as 3 times square root of 2. But what is this equal to, Mercedes? If I multiply this, what do I get?
I think you get, if you multiply all of it,
No, just this.
8.
3 times square root of 2 times square root of 2. What would that give me?
3 times, you say?
No, right here. I'm only doing this one. The numerator is going to stay the same. I multiply it by square root of 2, and that stays the same. The denominator, I put 2 times square root of 2, multiply it by square root of 2. What is that equal to?
Multiply by square root of 2.
Square root of 2 times square root of 2 is just 2. So that's going to be 2. Right? Remember I said when you take the square root of a number times itself, you just get back just the radicand, just the number.
Oh,
Square root of 2 times square root of 2 just gives me 2.
but you gotta put it back like the way you said it. You have to write it the way you have it there.
Yeah, then I'll put it all back together. The numerator is 3 times square root of 2. The denominator is 2 times 2, and that's 4, right? So what is my answer? My answer will be 3 times square root of 2. Let me just copy that. And what's in the denominator? I'll say these.
2,
No, 2 times 2. What's 2 times 2?
4.
4. So that would be 4. Okay. Now let me just put it together. Okay. Okay. Let me put this here. Okay. So what we're doing is we're saying multiply this. I'll put square root of 2. Numerator times square root of 2. Put that there. Okay, and then I want to multiply my denominator by square root of 2. So let's put that in parentheses. Okay. And underline all of that so you can see it all together. Okay. All right. Now I have 2 times square root of 2 in the denominator. So let me just put that there. And then multiply that by square root of 2. Put it here. Put my square root of 2. Now remember, square root of 2 over square root of 2 is just equal to 1, right?
Okay.
So that's how we can do it, because we can multiply something by 1 and it doesn't change the value, right? Okay. So I only need one pair of parentheses. Take the underline out so it doesn't confuse anyone. Okay, now square root of 2 is multiplied by both numerator and denominator. So what do I get in the numerator? I'll say these.
Oh boy. 4 or 2? Oh, 2, 3, bracket 2, 2 in, we call it radical.
Yeah, so the number, the numerator, I just have 3 times square root of 2. This doesn't change. I multiply it by square root of 2 and that just stays there.
So I'm just saying that should be the answer. Put it back.
No, that would be the numerator, right?
Oh,
Okay. Now, what would I get in the denominator, Maureen? I mean, Mercedes, what's in the denominator?
2.
2 times what?
2 and the radical between and 2. No, 2 and bracket radical 2.
No, radical times the radical just give me the number 2.
Okay.
Remember I said when you multiply radical times the radical, the same radicals, you just get the number, the radicand.
Oh yeah.
So that's just a 2, right? So
Yeah.
that would just be equal to 3 times the square root of 2 over 4. That's your answer.
Okay.
Maureen, are you following?
Yeah.
Okay, because I want you to do the next one. Okay, and at the bottom, the denominator, I just have the 4. There we go. Now I did it here in steps, but I think you can understand it better maybe if you just put the square root of 2 over square root of 2 multiplied by the expression. So square root of 2 over square root of 2 is just a 1. Now the numerator just stays 3 times square root of 2, and the denominator, square root of 2 times square root of 2 is the number 2, and then you had a 2 already. 2 times 2 is 4, and you don't need the parentheses here. I could take those out and just say 3 times square root of 2.
So, Miss, that you have to have the answer all out like that.
That's the answer. Yes.
2, 3 part.
No, if I say rationalize 3, that's the way the problem was stated. Rationalize 3 over 2 times square root of 2. It could be a multiple choice. It could be put the answer, and this would be your answer right here.
So the answer will be the last one. Okay.
Yeah, that's your answer. All right. Your answer would be 3 times square root of 2 over 4. That's your answer. Got it?
It seems strange when I get it.
Rationalize is called the rationalization of the radical, and we rationalizing the denominator. The denominator has a radical. We want to get rid of that radical in the denominator. How do we do that? Multiplying by radical.
Okay.
Got it? Okay, Maureen, number 2. I want you to do number 2. Let me just put here. Rationalize these expressions. Okay. We did the first one. And Maureen, I want you to do number 2. So what would you do, Maureen? Number 2.
Okay, we concentrate a little bit.
2 times the square root of 5. I'll help you out. Don't worry. Now, what are we going to multiply, Maureen?
Okay.
Remember, I'm trying to make that, let's see. Okay. Take that, that's number 2. We want to make that square root of 5 a number. That's what we mean rationalize. Change that square root of 5 to a rational number. So what do we do, Maureen? What's the first step?
You're a little confusing anyhow.
Okay, let me just put it in words here. The first step is to multiply by square root of 5 over square root of 5. So I'm going to put square root of 5. And that's 1, right? Multiply square root of 5 over square root of 5. So let me just put that here. So that's your first step, Maureen. So you want to multiply square root of 5 over square root of 5 by this expression, right? So let me just take this and you tell me what to write. That means you multiply the numerator by square root of 5 and the denominator by square root of 5, right? So you're going to have square root of 5 times the numerator. Let's just put that there. That's multiplication. And multiply the denominator by the square root of 5. Okay. All right. That's your first step, Maureen. You follow the first step? Maureen?
It says 2 by 5 and 5 by 5.
Yeah, you're multiplying the numerator by square root of 5 and the denominator by square root of 5. That's like multiplying the whole thing by 1. And we can multiply by 1 and we don't change the value, right? Okay, so what do I get for the numerator, Maureen?
Multiply 5 by 5, right?
No, the numerator says 2 times square root of 5. And that's just equal to square root 2 times the square root of 5. All right. So then I just put 2 times square root of 5. What do I get in the denominator, Maureen? What's square root of 5 times square root of 5?
1.
No. Remember I said the square root of a number times the square root of the same number just gives me the number. So what would be the number? The radicand. Number underneath.
5.
That's it. Very good. The number under the radical. That's your answer. 2 times square root of 5 over 5.
That's it?
That's it. Remember, the purpose is making your denominator a rational number. So you want to go from a square root of 5 to a rational number. No, rational number is the square root of 5. That's your answer. All right. Questions? So you're changing your radicals to a rational number, and you do that by multiplying by the radical. Okay.
Okay.
So you think you can probably do some of the simpler ones of these?
I thought those were simple.
Now, sometimes you're given these problems and you have, you may have to factor the number. All right, you may have to factor the number to get the answer. Like these were prime numbers, right? The 5 is a prime number. But if you have numbers that are not prime numbers, then you may have to factor them before you do your radical. Like the square root of 20. See that? You'd have to take the 4 and the 5. You know how we've been breaking the square roots into 2 square roots? So it'd be square root of 4 times square root of 5. Square root of 4 is a 2. And now you multiply the square root of 5 times square root of 5. You follow what I'm saying for number 3?
Repeat it, please.
Okay. For number 3, and I want you to try this one, but this is one where you have to do some factoring before. So let me just, because
Are
the
you
square root of 20 factors into what, Mercedes?
4 and 5?
That's right. So let me just say what I'm saying. I want you to finish this one. All right. Okay. So let me just put, now the others we just straight out multiplied by the radical. But like I'm saying, some of them you sometimes have to make the denominator into 2 radicals in order to simplify it. All right. So this becomes square root of 4. And what follows this, Maureen? 20, square root of 20 factors into what, Maureen?
4 and 5.
That's right, 4 and 5. Very good. So then you put square root of 4 times the square root of 5.
Root of 5.
All right. So you have to do this first. All right. This is, you take out the 3. This is not, okay, let me take out this. Okay, so you'd have to say 3 over factor of 4 and 5. So what's the square root of 4, Mercedes?
Square root of 4 with 2.
That's right, very good. So that's a 2. So let's just copy that. And now this is a 2 times the square root of 5. Now you multiply the square root of 5 times square root of 5. You follow? So now you multiply square root of 5 times the numerator, square root of 5 times the denominator. So this becomes, let me put square root of 5 times that's multiplied the numerator and square root of 5 in the denominator. All right. Let's just put our underline here. Okay, now what do I get for the numerator, Mercedes?
For this one,
It just the square root of 3 times square root of 5, right? See the numerator, we just repeat it. Square root of 3 times
yeah.
square root of 5. What do I get for the denominator, Mercedes?
3.
What's 2 times square root of 5 times square root of 5?
I'm not sure if I should multiply it or what.
Maureen, you know, what's square root of 5 times square root of 5?
Is it
1.
5?
Maureen?
1.
No, square root of 5 times square root of 5 is just 5.
Oh, yeah.
Right? Remember I said the radical times the radical itself is just the radicand. So square root of 5 times square root of 5 is just 5. So this will be 2 times 5. So what's the answer? Square root of 3 times square root of 5 over 10.
Oh,
Got it? And 2 times 5 is 10. That would be your answer.
Mm.
So I gave you one where you had to simplify before you could rationalize. All right. So
okay.
this would be your answer.
What still, Mr. King? Oh, does the number 3 mean you should get 3 figures for the answer?
You should get one.
3 figures for the answer.
No, your answer is numerator over the denominator. But remember,
Yes, miss.
your
That's-
denominator is the one that you're trying to change from radical to rational number. So the numerator still has radical in it.
I guess you don't understand my question.
What's the question?
Remember that 4 and 5 divide up 20, right? So I'm saying, is it what's the reason for 3 up there to begin
Well, the
math?
3 was part of the original.
Oh,
Rationalized square root of 3 over square root of 20.
well,
That's
gotcha.
part of the expression that you rationalizing.
Okay, okay.
All right. So you can't throw away that 3. That's part of the what you rationalize it. But since you rationalize the denominator, you have square root of 20, but square root of 20 factors into, that's why I say sometimes you have to simplify first. So square root of 20, we've been doing this, we've been breaking our radical into 2 radicals, square root of 4 times square root of 5. But square root of 4, perfect square root, that's a 2. Then we multiply both numerator and denominator by square root of 5. That's like multiplying by 1. When you're multiplying radical times radical, you get the radicand. Okay, square root of 5 times square root of 5 just gives you 5. Square root of 10 times square root of 10 gives you 10. Square root of 100 times square root of 100 gives 100. Got it? So square root of 3 times square root of 5 over 10. And we got our answer. All right. Now, this could be expressed also as what? What could I express this numerator as? Maureen, what could I express that as?
You mean the 10?
What's square root of 3 times square root of 5? Square root of 15,
Mm-hmm.
right?
Miss,
Yes.
I think 50, but I'm not sure.
Yeah, it'd be 15 because 15, square root of 15 can be broken down into 2 radicals, square root of 3 times square root of 5. So, because that could, if this were multiple choice, that might be one of your answers, square root of 15 over, and this would be a 10, right? That's also a way of expressing the answer. And that's the same, right? The reason I'm giving you both, because sometimes they combine them and sometimes they are separate. So you've got to know both answers here. Okay, you got it?
Okay.
Because it's like if you had square root of 15, you broke that down into square root of 3 times square root of 5. But you could just really put it all back together and have square root of 15. Got it?
Okay.
So you think you're able to rationalize?
Mhm.
Well, you won't get any on your next homework. We'll do some more. But your next homework will definitely have what we've gone over with the simplification and also the simplification of the radicals and also the scientific notation. That would be on your next homework. All right, we're going to stop here. But rationalization, we'll do some more of those next time. I won't give you any homework on your rationalization. We'll do some more practice. But I said we will have homework on simplification, of radicals and also on scientific notation. Any questions on anything we've gone over?
I have to look at what I